We're going to be learning about long division right now, but I wanted to start off with just a couple of quick items. First of all, we know that multiplication is repeated addition. For example, 3 times 4 means we're going to take this 3 and we're going to add it 1, 2, 3, 4 times. Or we could say we're going to take that 4 and we're going to add it 3 times. Either way, multiplication means that we're going to be repeating and adding over and over. Now, division is what we would call the inverse operation. The inverse of multiplying is division. And the undo, the inverse of adding, would be subtraction. So division is just the same thing as repeated subtraction. Because of this fact, we can actually do one version of division like this. We could say 12 divided by 4 means we could say 12. We're going to subtract 4. There's once. We could subtract 4 again. That's twice. And we could subtract 4 one more time. That gives us 3 times. So we count up how many times we did that. That's once. That's twice. That's 3 times. So 12 divided by 4 would be equal to 3. In the same fashion, we could take 12 divided by 3 and we go 12 minus 3 gives me 9. That's once. We could subtract another 3. Remember, we're repeatedly subtracting. That gives me 6. We could do it again. And I could do it one last time. That was, let's see, there's once, there's twice, there's 3 times, there's 4 times that we subtracted, which tells me that 12 divided by 3 is equal to 4. Okay, that is exactly what we would expect from the inverse properties. Now, this is not long division, but it is giving us an idea of what division is sort of doing. Now, long ago, they developed a method we call long division. There's various different versions of doing it, but it's basically we're just taking a number and we're slicing it into equal parts. We're just subtracting the same amount from it each time and figure out how many of those groups we have. Now, one way that you can remember this is, let's see, D, M, S, B. So you divide, then you multiply, then you subtract, then you bring down. That's sort of how the process goes. You just repeat that over and over. So let's give it a try. We're going to do 84. So I'm right here. We're going to do 84 divided by 6. Now, let's see. The first number goes inside. The second number goes outside. So when I set this up, it's going to look like this. We're going to go 84 is on the inside. 6 is on the outside. Keep track of how we do this because it's going to get a little bit... it's going to get repetitive. I'm going to take a look at this 6. I'm going to say, how many times does that 6 go into that 8? Well, the 6 goes into 8 once. We're going to take that. That's the first step. That's the divide. 1 times 6. And then we're going to subtract. And we get 2. And then we're supposed to bring down. That 4 gets brought down. Now I look at this 6, and I'm going to ignore this 84 entirely now. 6 goes into 24. Let's see. Oh gosh, I don't really know. So what I could do is I could remember that the multiplying process is going to be the same every time. So I'm going to do this trick. I'm going to write out a list of all of the possible numbers, 1 through 9. And then I'm going to do multiples of 6. So 1 times 6 gives me 6. 2 times 6 gives me 12. 3 times 6 gives me 18, and I can just keep adding 6's all the way down. So I'll get 24, 30, 36, 42. Let's see, adding on 6 again, that's 48. Then adding on 6 again, that'll be 54. Okay, so I need to know 6 goes into 24. That's the one I'm looking for right there. So 6 goes into 24 4 times. 4 times 6, 24. All right, so this lets me conclude that 84 divided by 6 is this top number, 14. Not too bad, right? I'm going to move that over a little bit. Now, this works perfectly when the numbers make sense like that. So 6 and 84, it slices up really nicely. I didn't have to worry about any repeating decimals. I didn't have to worry about a remainder or anything like that. So we're going to take a look at what happens if I have 8.4 divided by 6. So I'm going to set it up exactly the same. The original number goes outside. Okay, so the first one is inside, the second one is outside. And I'm going to ask the question, 6 goes into 8. See, 6 goes into 8 just one time. Nothing's changed. 1 times 6 gives me 6. This works very nicely. And now what I'm going to do is I'm going to bring down that 4, and I'm going to ignore the decimal point in my calculations. But I am going to take that decimal point and move it straight up. So that decimal point, just keep it up there. Now I do the same calculation. 6 goes into 24. That's 4 times. 4 times 6 gives me 24. Just like I expected it to be. There's no remainder. And what I find is that my answer is 8.4 broken into 6 equal parts is 1.4 each time. Not too bad, right? So let's do another one. We're going to do 84 divided by 0.6. This one's going to be a little bit trickier. So let's see. It's the first one goes outside or inside, right? First one goes inside. The second one goes outside. And I don't like this 0.6 thing. That 0.6 is really bothering me because, I mean, I know I'm going to need a lot of 0.6s to make 84. I mean, it's less than 1. It's going to be like a really big number. What I'm going to do is I'm going to take that decimal place and I'm going to make it easier by moving it over 1. So this decimal place, 84, I'm going to move that over 1 as well because I know that this doesn't change the value if I move them both over when I'm doing division. It's a trick, but it's a pretty good trick. From here, what I can do is I can say, I'm going to rewrite this. Now I have 6 goes into 840, and it's exactly the same value, but represented slightly differently. 6 goes into 8, goes in once. 1 times 6 is 6, and I subtract to get a 2. I bring down. 6 goes into 24. Let's see, that was 4 times. 4 times 6 gives me 24, minus a 0, and I bring down the 0. 6 goes into 0, a total of 0 times. When I multiply, I get a remainder of 0. That kind of was expected, wasn't it? And that means that my final value here is 140. If I take 84 and I break it up into parts that are 0.6 in size, I'm going to have 140 of those parts. Okay, that decimal trick was pretty helpful, I think. Last but not least, 840. That's my first number, so it's going to go inside. The second number is going to be 0.06. That's going to go outside. And, oh man, that is bothering me so much. I really do not like having so many decimal places. So I'm going to take this decimal, and I'm going to move it over 2 times. And this 840, I'm going to have to move that over 2 times as well. Okay, so I'm going to divide. So 6 goes into the first digit here. 6 goes into that once. Then I multiply. 1 times 6 gives me 6. And then I subtract. That gives me 2. And then I bring down. Okay. 6 goes into 24. According to this, it's 4 times. 4 times 6 is 24. If I bring down a 0, that's going to give me 0, right? It's going to go in exactly 0 times. So I can kind of repeat this bring down process over and over until I get to the end of my number. So that tells me that 840 divided by 6/100ths, I'm going to get 14000. That's 14,000 times. So 6 cents, how many collections of 6 cents do you need to get to $840? You need 14,000 collections of those. All right, that should be a pretty good demonstration of some long division process. We haven't gone into anything like remainders, so we haven't worried about that. I hope you've noticed a couple of other small tricks as we've gone through it.